Welcome to our podcast, where we cover unique and interesting stories for you. In this episode, we will discuss scientists uncover strange details about Mars's mysterious moon. While analyzing some old unpublished images of Mars's moon Phobos, researchers found something peculiar that might prove our previous understanding of the moon wrong. Phobos, also known as the doomed moon, is a little different than other moons of the solar system. It is much smaller than its host planet and is covered in craters with surprisingly low density. Another such moon of Mars is Deimos. Both Phobos and Deimos have similar characteristics and are very irregular in shape. The close-up images of these distinct moons show Phobos has 1 kilometer-long grooves running across its surface, which is unusual for a moon. The images also show Phobos covered in loose regolith. There are some theories related to the formation of these moons, though none explain their unusual characteristics completely. According to one idea, the moons were created when a large object collided with Mars, creating a debris disk around Mars that slowly coalesced into the objects. Another suggests that the moons are captured D-type asteroids, usually found in the outer asteroid belt, or with Jupiter's Trojan asteroids. The latter asteroid theory might explain their apparent composition, but it falls short of explaining their almost circular orbit. Meanwhile, the debris disk hypothesis might explain the circular orbit, but doesn't do well for the moon's composition. A team of researchers from France and Germany came across previously unpublished photos of Phobos taken by the European Space Agency's Mars Express spacecraft, and found the moon does not reflect light uniformly, but appears brighter when the sun is directly overhead, something which is seen in comets. Overall, our photometric analysis has shown that Phobos' photometric properties show a close resemblance to those of Comet 67P. Both have a red spectrum, a high surface porosity, and similar opposition effect values, the team wrote in their study, adding that the moon could be a bilobated comet, that is, comets with two distinct lobes, or a binary comet, composed of two bodies that have come together through gravitation. When the team compared the phase integral and geometric albedo of Phobos with other dark solar system bodies, it showed that Phobos has photometric properties similar to those of Jupiter family comets. This is a unique hypothesis, as thus far we have not discovered any comet moons, making Phobos a potential first. The upcoming Japan Aerospace Exploration Agency's Martian Moons exploration mission, launching in 2026, aims to return samples of Phobos to Earth after 3 years of observations. With its sample, the hypothesis can be proved true. That's all from this podcast. Thanks for tuning in. If you enjoyed this episode, be sure to subscribe and share your thoughts in the comments. Stay connected for more exciting discussions and updates in our next podcast.